I didn't see you there. But while you're here, welcome to our 2022 Fall Capstone Final Video Project. My name is Paul Crandall, and I'm joined by my fellow group mates Gail Yee, Gracie Burgess, and Alyssa Bose. We're here to talk to you about working with our company all semester, Radar Manufacturing. Great knife company to work at. So come with me, and without further ado, let's begin our Capstone Video Report.
Let's move on to the scope of our project.
Thank you, Gail. I'm Alyssa Bose, and I'll be talking about some of the objectives that we focused our project around. Initially, we were given a material handling improvement project, so the focus was to decrease work in process inventory by 20% while increasing enough room on the floor to create about 333 square feet for the new hollow grind coming in next spring. From the current state analysis, the team was able to identify several factors that initiated the future state designs. The bottlenecks of production were identified to be the hollow grind machines, which was a main focus for the team, specifically taking into account issues within warehouses 1 and 3. Through inventory mapping and capacity analysis, the team concluded that more than 50% of inventory had been sitting for more than 2 months, and this storage freed up would suffice enough space for the new hollow grind machine, a requirement of 47,904 inches squared.
Now that we've discussed the objectives and the scope of this capstone project, let's dive into some of the main components related to the current state analysis. The first of those components would be inventory mapping, and the goal of this study was to get an idea for what inventory was where within warehouses 1 and 3 and for how long it was sitting on those shelves. Of this study, we found that empty shelves contributed to 9.3% of all of the inventory found, as well as 16.3% of that study was unlabeled inventory just sitting on the shelves. Additionally, over 55% of this observations was there longer than 2 months, with just about a quarter of that 55% dating back since before May, even including observations from the previous year.
During the work sampling study, observations were made every 2 minutes, and each operator was surveyed individually, and their data was recorded in a work sampling chart. A total of 470 observations were made. A total of 118 observations were value-added activities, while 155 observations were non-value-added but necessary, and 221 observations were non-value-added activities.
For the next portion of the current state analysis, a capacity analysis was conducted on warehouse 3 and 1 as a specific placement for the location of the new hollow grind machine needed to be identified. Within this area, the layout was analyzed and broken down into what percent of space was occupied by which machine area. Within this, it was determined that 333 square feet would be required to fit the new hollow grind machine. It was determined through a process flow analysis that the process flow would not be altered in any way from the before to the after layout.
Moving on to the future state design. First, we worked with the engineering team at RADA. We determined that the optimal solution is to implement a vertical lifting module that can hold at least 1,300 boxes within a smaller floor space. It will help manage inventory through integration with the barcode tracking system and keep track of when boxes are added and removed from the module. Along with the module, we recommend adding a pallet rack that will store the reworked parts near the equipment needed and out of the way.
The team incorporated a barcode tracking system as a long-term design solution for RADA's production center. The tracking system addresses the objective of still being able to track inventory with the decrease in inventory space and the increase in storage capacity at the same time. After choosing the FlowTrack software as a solution the company was going to implement, research on barcode tracking system was further broken down into 3 main focus areas, specifically the hardware, software, and station layout. For our hardware, as you can see on the screen, we have our barcode printers, our barcode scanners, and our computers.
The last major component of the future state design relates to SOPs and 5S, lean manufacturing tools. Specifically, with implementing this part of the project, the focus was on standardization and creating documentation for current employees as well as future training purposes. The first is an SOP template on the left, which features sections such as safety requirements, required materials, and then the individual steps. The second document seen on the right is a 5S standard, which includes several descriptions of each step of 5S, the frequency of when different tasks need to be performed, as well as a space to provide any visual aids to help operators and engineers understand what goes where.
For our ROI, we determined that the barcode system, after having all of the equipment needed, would cost $36,550, and then taking that and including the lift module at $151,000 for implementation and the purchase of the lift module, $3,500 for and-on system, and then $328 for 10 SOPs. And then moving the machines for $1,400. We also determined that the lift module would have a return of $84,000, but with the increased capacity that it provides of $210,000, and then the barcode system having a return of $134,000, we have an overall ROI of $231,000.
Thank you for watching our video, and we hope you learned a lot about Radar Manufacturing.